Welcome back. I want us to understand how things work underneath the hood. So I'm going to show you two examples of implementing our own for loop and then implementing our own range function. So the first one is our for loop. So I'm going to say special for loop. Underneath the hood, all it's doing is receiving an iterable, and then we're going to say iterator is going to equal an iterable. Now, for us to have an iterable, we have what we call an iter function that accepts the iterable we just passed. Now, this iter function is going to allow us to use the next function on this iterable. So stay with me. I'm going to say while true, I want to try. And in this try block, we'll say iterator. And we can perform, let's say, some sort of operation here if we want, or we can just call next iterator. You know what? Let's print something here just so we see what the iterator is. And then finally, I want us to stop when we have the stop iteration exception. Remember the one that we saw where there's no more items in the iterable. And here we simply can just break. Ooh, and make sure that I have the colon set correctly. So now, if I do special for loop and give it a list of 1, 2, 3, and I click run, check it out. I loop through some iterable objects using next. And you see that this object exists in the same memory space, even though we're constantly looping through it through 1, 2, 3. So this is how for loops work underneath the hood. When we do for, let's say num in and then give it a list, it's going to go through everything. It's going to turn it into an iterable, and it's going to keep running and keep calling next iterator on it over and over and over until we finish the end of the line and then break out of the loop. And how do we check the actual values of the iterator? Well, remember the next function is going to output whatever the item is next. So if I do print here and I click run, I get 1, 2, 3. So I can just do times 2 if I wanted to, click run, and there you go. Our special for loop just multiplied our list by 2. That's it. That's how for loops really work. But what about ranges? Can we create our own range function? We absolutely can. And this is a fun one. Let's create a class. And this class, because at the end of the day, we're just going to create an object that has actions that we can do. So I'll say my gen for my generator. And this is going to mimic what our range does. So I'm going to have a class. And this class will have a init function. We'll have a self, a first and last. So this is how a range, we're able to say start with this and end with this. And in here, we'll do the typical self.first equals to first, and then self.last equals to last. And I'm using a class here because remember, we're just creating our own data type, our own special range in Python. Now, we have our simple generator. And ideally, we want to be able to say gen equals and instantiate my gen to have, let's say, 0 to 100, just like we would with a range. And ideally, we can say for I in gen and print I. Because, I mean, that's how we're able to use ranges, right? So how can I make this work? Well, we can use our dunder methods. So remember how we have the iter to get an iterator and use next on them? Well, we have a define dunder that is iter. An iter allows us to create an iterable. So in our case, I'll say self, and here I'm just going to return the actual class, like so. And then finally, we want to be able to run the next function on our gen, because we saw how for loops work. We need to be able to use the iter and then the next on them. So once again, we can use a dunder method, which is conveniently called next. And this is built into Python. So if I do here self, and all we want to do here is to let it know how we want next to work. Well, I'll say if, and we need some sort of state or data to keep track of where we are. Remember how generator functions remember where they are? Well, we can create a class object attribute. So I can say current equals to 0. So this is where we are currently on our iteration. And say mygen.current, as long as that is less than self.last, which will be the 100 here. If that's the case, well, I want a number to equal mygen.current. I want to increase mygen.current by 1 because we want to say, hey, we're moving up to the next location. And then return the number. Because that's how next works underneath the hood, right? We increment our current location by 1, and we're simply returning the number, which is, well, in our case, it's going to be 0. And we want to keep going, well, until current is no longer bigger than last. In that case, we're simply going to raise a stop iteration because there's no more things to iterate over. Let's see if this works. I'm going to run this. And look at that. It's all working. I was able to loop through my generator and print I from 0 all the way to 99. Again, if we go back to our example here, and I know this is a little hard to look at it at first, but all I did was say I want an init function to have the option of first and last, and I'm going to want to be able to iterate through this object that I'm going to create, and I also want to be able to use the next, which for loop, if you remember from our previous example, needs. So I'm going to say for item in gen, just loop through it. I'm able to loop through it because this is now an iterator, and I'm able to use the next value on it because I allow us to loop and constantly increase by 1 until we keep returning the number until mygen.current becomes 100. And 100 is not less than 100, which is self.last, so it's going to raise a stop iteration. The for loop automatically catches that, so it doesn't error out, and it stops looping. That's how things work underneath the hood with range. Now, you don't need to know this. You're not going to be asked in your day-to-day to implement this, but I wanted to show you that this is how things work. I think that's important.